So a loan department in a bank will use at most $25 million for commercial and home loans. The bank's policy is to allocate at least 4 times as much money to home loans as to commercial loans. The bank's return is 12% on a home loan and 10% on a commercial loan. The manager of the loan department wants to earn at least a return of $2.8 million. Let's find the feasible region. So the first thing I'm going to do is I'm going to go ahead and write out what my variables are. For this problem, we're working with two things. We want to have the amount for the home loans and the amount for the commercial loans. That's what we're trying to decide. So let's let X be the amount for the home loans and Y be the amount for the commercial loans. So we know that the variables in this problem must be positive or zero since we're talking about amounts of money loaned. So right away that gives me two inequalities. X is greater than or equal to 0 and Y is greater than or equal to 0. When we graph this, that's basically going to mean we're working in the first quadrant. These are typically called non-negativity constraints because they're saying that the variables are not going to be negative. The loan department in the bank will use at most $25 million for commercial and home loans. So that at most tells me that we're talking about an inequality. So the inequality we're talking about here is that we're not going to have more than 25. So that means that X plus Y is going to be less than or equal to 25 because the total amount loaned has got to be smaller or equal to 25. So notice I've decided to put my variables in millions, and so I've added that to my description above here. I didn't write out the entire 25 million, I just wrote out 25 here. Now we know that the bank's policy is to allocate at least 4 times as much money to home loans as to commercial loans. So that gives me the inequality that X is greater than or equal to 4Y. Because remember, Y is the commercial loans. 4 times that is what's going to be equal to the home loans, or the home loans are going to be bigger than that. So this says that the home loans are going to be greater than or equal to 4 times the commercial loans. Lastly, the manager of the loan department wants to earn a return of at least $2.8 million. So remember, those returns come from 12% of the home loans or 10% of the commercial loans. So we write out 0.12x because we're going to get 12% of x plus 0.10y because we're going to get 10% of the amount in commercial loans, and then we need at least 2.8 million. So at the very worst, it'd be equal to 2.8 million, but we actually want greater than that. And so what we see here now is our system of inequalities. So let's write that off to the side now, and let's start working with our graph. So the first thing I'm going to do is I'm going to take that first inequality, and I'm going to graph the line 0.12x plus 0.10y equals 2.8. And that's the line that you see in gray here. If I test the 0.00 in here, I get that 0 plus 0 is greater than or equal to 2.8. That's a false statement. So that's why we've gone ahead and shaded everything above the line instead of below the line. Now let's go ahead and draw the line x equals 4y. So when I graph that line on here, you see it right there. And if I were to test a point down here like 15, 0, I would get 15 is greater than or equal to 4 times 0. That's a true statement. So everything below that line gets shaded. And when I overlap it with what I already had, I just get that small region down here. Now let's look at the next inequality. This one is the line x plus y equals 25. So that's the dark gray line that you see on here. And if we check 0, 0 in here, 0 plus 0 is less than or equal to 25, so we want everything below the line. So when I intersect that with all the other regions, I get this little tiny region down here. Now the last thing I'm going to look at is our non-negativity constraints that say we need to stay in the first quadrant. So when I put that in, I see this little sliver down here is my feasible region. So the next thing we want to do is start finding where some of our corner points are. So I'm going to take a look at the x equals 4y line and the x plus y equals 25 line to find that corner point right there. So I've taken my two equations here. I'm solved for x, so I'm going to substitute 4y in place of x, and when I do that I get 4y plus y equals 25, or 5y equals 25, which means y is 5. If I put that in place of that first equation, I see that x is 4 times that, so that's 20. So this point right here is 20, 5. Now let's go find some of the other corner points. So now let's go ahead and look at the x equals 4y, but now we're going to look at the 0.12x plus 0.10y equals 2.8. So let's find that corner point. So again, it's easiest to use substitution here. So I'm going to put in place of x 4y. 4 times 0.12 is 0.48 plus 0.10y gives me 0.58y. So now since I have 0.58y equals 2.8, I'll divide both sides by 0.58 and I get that y is approximately 4.83. If I put that back into that first equation, 4 times that y means the x is approximately 19.3. So I've gone ahead and I've kept a few more decimal places here. And so this other corner point is 19.31, 4.83. And the other corner points are fairly easy to find because they're just intercepts of some of the other lines. They're at 25, 0 and 23.3, 0. So now I have my feasible region. I have all my corner points. If this was part of my linear programming problem, it would be very straightforward to solve, and that's what we're going to do in the next section.